Hello guys, good day to you. Welcome to our class for today. Today we are going to be looking at resistors, connection of resistors, resistors in series, resistors in parallel. We'll also discuss cells in series, cells in parallels. Then we'll do some calculations. Is that okay? We've already started introduction to current electricity, so we are progressing as I've said before. Okay, so welcome to this class. If you have not subscribed to our channel, please, what are you waiting for? Please subscribe to our channel. Um, Click on the notification bell so that when we upload a new video, YouTube will notify you. Also, I'll encourage you to invite your friends to come and join this wonderful class. Besides that, please give us a like. If you like what we are doing, give us a positive comment, give us a like, and then so that you can encourage us, right? So this is Nobleman Science Tutors Online. You are welcome to our class for today, and I remain Otobo Michael. So if you are ready, let's go straight to our class for today. Continuation of current electricity and connection of resistors, parallel and series, right? So let's go. Okay, so in our previous video, I introduced the Ohm's law, and it's the same thing that is here. Ohm's law states that the current flowing through a metallic conductor is proportional to the potential difference across its ends, provided temperature and other physical conditions of the conductor are kept constant. So I've discussed it before. Mathematically stated, current is proportional to the potential difference, and then the constant of proportionality rho is the resistance of the system or the resistance of the wire of the cell. So mathematically you can have I is equals to V over R, or R is equals to V over I. These equations are very key when you are talking about current electricity. Okay, so please take note of these equations, these three equations. They are very key in solving problems in current. Once you know this first one, V is equals to R, the other ones you can derive them. The other equations, they are derivation. These other two derivations of this first equation just by changing the subject of formula. Is that okay? So this is just the basic, and then the basic and the law that governs current electricity. All right. So we're moving on now to resistors in series. Okay, so but before we talk about resistors in series and that series connection, we need to know, though we've discussed about electric circuits in our previous class, so this is just like a summary information. So basically an electric circuit consists of the following. So this is just a diagram of a typical electric circuit, right? So one, it contains the source of electric energy, which is the battery, and the battery is also known as a cell. Okay, then it has a switch. It must have a switch. This is the switch or the key. It is this switch that can stop or allow the flow of current. So when you close this, it becomes a closed circuit and current will flow. If it opens, it becomes an open circuit, a current will stop to flow. Then the ammeter for measurement of the current that is flowing. Then you have the voltmeter. Okay, you have the voltmeter that measures the voltage between 2 points, or the potential difference between point P and Q. Then you now have a resistor. A resistor can be in the form of a bulb or a load. So you have a resistor here, then you have a rheostat. This rheostat is used to adjust the flow of current. Okay, so this is basically the setup of an electric circuit. So this is a simple circuit diagram, and it is good that you should be able to learn how to draw simple circuit diagram. Yes, it is very important, and it is pertinent. So if you don't know how to draw a circuit diagram before, please go and watch the first video on this, Then come and also look at this one, compare the two, and practice how to draw simple circuit diagram. Is that okay? Because there are some questions that you'll be given, they will not draw the circuit diagram for you. You have to interpret the question before you can solve the problem. So you should be able to draw a circuit diagram as a good physics student. So please practice how to draw simple circuit diagrams, right? So now we're going to look at a circuit, or yes, a circuit or resistors that are connected in series, and how you can find the overall resistance, right? Okay, so this is electric circuits and connection of resistors. This is series connection. Series connection. In series connection, the resistors are connected end to end. Look at it. This resistor 1, it is connected. This is the first one. This one is connected to the end of the first one. The third one is connected to the end of the second one, just like that. Now, basically, what you should know is that when resistors are connected in series, their overall resistance is the sum of all the resistors, or it is the sum of the individual resistance of the resistors. Is that okay? So like here now you have three resistors, R1, R2, and R3. So their overall resistance is equal to R1 plus R2 plus R3. Very simple. Very simple. If you look at the arrangement, you find out that they have different voltmeter that are connected across their terminals. This is voltmeter 1, voltmeter 2, voltmeter 2, and each of them they are measuring the different PD, different potential difference. Okay, so if you look at this very well, you find out the current that is flowing through a series arrangement is the same. It is the same current that leaves this ammeter. It is the same current that leaves this particular ammeter that is reading it, that flows. So anything that this ammeter reads, that is what will flow through all the resistors. Okay, then the voltage, the overall voltage of this arrangement is the sum of the individual voltages, the sum of the individual potential difference. So which means in this case, for you to get the overall PD, you have to add V1 plus V2 plus V3 as the case may be. It is only V1, you take V1, it is only V1 and V2, you add the two. If they are up to 4, you must add everything together to get your overall voltage. Is that okay? So, and that is what is I stated here. The overall voltage V is equals to V1 plus V2 plus V3 as the case may be, while the current is the same current, right? The current is the same. There's no change in the current that is flowing. It is the same. Okay, so this is what you should note. So if you are given any question, please take note of these two informations. They are very, very key. Okay, the sum of the overall resistance is the sum of the individual resistance. Then the overall voltage is sum of all the voltages. Current is the same thing. Okay, current is the same. So I hope that is clear. If that is clear, then we can easily solve this problem. Say three resistors of resistance is 1 ohm, 2 ohm, 4 ohm. I think I've not mentioned this, but know that resistance are measured in ohms, right? Resistance is measured in ohms. So three resistors or resistances, 1 ohm, 2 ohm, 4 ohm, are connected in series. Calculate the equivalent resistance of the combination. So what they're asking you to do here is to calculate the overall resistance or the effective resistance. So you have that R1 is equals to 1 ohm, R2 is equals to 2 ohm, is equals to 2 ohm, and R3 is equals to 4 ohm. So we said that the overall resistance is equals to what? R1 plus R2 plus R3. So basically just for you to add them together so that you have your answer. Okay, so this is relatively very simple. I don't know, but many questions in electricity, they are very simple and direct. Okay, so this is your overall resistance. I think this is quite simple, right? Fine. So we can go to the next slide. This is circuit in parallel. Circuit in parallel. This is how resistors are arranged in parallel. In this case, they are arranged side by side. Side by side. So this is a parallel arrangement of resistors. Now if you look at this arrangement, you find out that this current that is coming is distributed. So the current is not the same. The current that is flowing through the resistance or through the resistors or through the bulb, they are not the same. They are not the same. So in this particular case, to find the overall resistance, you have to do this. Okay, so you find the LCM of all the resistance, then you now find the reciprocal to get your overall resistance, right? Then in this case, as I said before, the overall current is the sum of the individual currents. Okay, the overall current is sum of the individual current. Then the voltage is the same. If you look at it, the voltmeter is connected across all of them, so the voltage remains the same. So V1, the voltage that is here is equals to what is here is equals to the voltage that is here. So V1 is equals to V2 is equals to V3. Okay, but I is equals to I1 plus I2 plus I3. So you need to take note of all this, because when you are solving any problem, these are the informations that will guide you. Yes, these are the informations that will guide you when you are solving any problem on current electricity. Okay, so you need to take note of all this. Alright, so let's go straight and see how we can solve overall resistance for a circuit arrangement like this, where resistors are arranged in parallel. Okay. Okay, so this question says that if three resistors of resistance 2 ohm, 3 ohm, and 5 ohm are connected in parallel, calculate the equivalent resistance of the combination. Okay, so first of all, you draw the drawing, yeah, right? You can just draw it the way we drew the other one. So these are, just draw it so you have okay, so this is one resistor, so another one, and this is another one. So this current that is flowing, so you have 2 ohm, you have 3 ohm, and then you have a 5 ohm. Okay, so we said that overall resistance is 1 all over R is equals to 1 all over R1 plus 1 over R2 plus 1 over R3. So when you substitute into this equation, you're going to have 1 all over 2 plus 1 over 3 plus 1 over 5. So what you now do is that you find the LCM of these three variables that are given to you. The LCM of 2, 3, and 5 is 30. Okay, so 2 divided 30 is 15. 3 into 30 is 10. And 5 into 30 is 6. So by the time you do your addition there, you are going to have that 1 all over R is equals to 31 over 30. Therefore, R, which is the resistance, is equals to 30 over 31, which gives us 0.97 ohm. Okay, so this is how, no matter how the resistors are given to you, just this how to solve it. If it is 2, you will use 2. If it is 3, just like this. So when resistors are connecting the parallel, you find the sum of the reciprocal. Okay, you find the sum of the reciprocal of each of the individual resistances. Alright, so I hope this is clear and understood. Thanks. So we've done resistance or resistors. So here we are looking at cells. Okay, cells are the source of electric current. So we are looking at cells. So cells in series, just the way they connect resistor, that's how we also connect cells. So when cells are in series, they are connected end to end. And for cells that are in series, just like when resistors are in series, the overall EMF of the cell is equal to the sum of the individual EMF of the cells. Is that okay? Then the total internal resistance, the same thing for resistors in series, just add them together, you have the total internal resistance of the cell. Okay, so this is for cells that are in series. All right. Then for cells that are in parallel, the same thing we did for resistors in parallel. For cells that are in parallel, right, their total internal resistance equals to the reciprocal. It's equals to the sum of the reciprocals of each of the internal resistances of the cell. Then for cells that are in parallel, their EMF is the same. Their EMF does not change. It is the same EMF that is in R1, the same EMF in R2, the same thing in EMF in R3. So the EMF is the same. It does not change. Okay, so this is for cells that are in parallel. So this is all about connection of cells and then connection of resistors. Okay, so what we'll be doing next now is to solve some problems to drive home the points that we have discussed so far. Okay, so we are going to solve some problems now. Okay, so this is a typical connection of resistors. This one says calculate the effective resistance of the circuit below. Now when you look at this circuit arrangement, you find out that some of the cells are connected in series while some are connected in parallel. So when you have a situation like this, what you do first of all is look at the parallel sides, right? So you first of all solve for the parallel side before you now make everything to be series. Then you add up your total resistance to get your overall resistance. So if you consider these cells that are in parallel, we'll have that their overall resistance is 1 over R. Overall resistance equals 1 over R is equals to 1 all over 2 plus 1 over 4. So when you work that out, you are going to have 4 as your LCM. 2 divided 4 is 2 plus 1, which gives us 3 over 4. So R over R is equals to 3 over 4. Then R is equals to 4 over 3. So if you divide that out, you're going to have 1.33 ohm as your overall resistance for this particular for this particular parallel arrangement. The overall resistance equals to 1.33 ohm. Now once you have gotten this, you can now redraw this circuit diagram. You can now redraw it. So when you redraw it, you have everything in parallel. So you're going to have something like this. So you now have, this is your 5 ohm, this is your 10 ohm, and this is your 1.33 ohm. Okay, so everything now is in series. Alright, everything now is in, and you know that for series arrangement, the overall resistance is the sum of the individual resistance. So this now makes it easy for us to solve that R is equals to, now will now be 5 plus 10 plus 1.33. Okay, so by the time you add all that up, you have your overall resistance. You will have your overall resistance to be 16.33 ohm. Okay, so you see that in this particular question, we had a combination of series and parallel arrangements. So when you have a combination of series and parallel arrangement, first of all, consider the parallel arrangement part, so that at the end of the day, you now draw the circuit and everything will become series. So when you have found the overall resistance for the parallel side, you now redraw your diagram, and then you can now add up and get your overall answer. So when you have an arrangement like this, first of all, finish up with the parallel arrangement so that you can have everything series. Then you add up your values and get your overall answer. Okay, so I hope this one is clear. This is another sample question. Say a fuse is rated 15 amp and operates normally on a 12-volt battery. Calculate the resistance of the fuse wire. Okay, so if you look at the equation we had before, we had that potential difference is equals to current times resistance. So here you are giving current I to be equals to 15, and you are giving voltage or potential difference to be 12 volts, because simply resistance will be equals to voltage over current. Okay, so that means your resistance will be equals to 12 all over 15. 12 over 15. So you can just work this out so that you have your answer. You have 0.8 ohm. Quite simple and easy. Okay, so you have 0.8 ohm as your answer. I hope this one is clear. So if it is clear, let's stick to another one. Okay, so this is another question. This one says calculate the current in the 3 ohm resistor in the circuit diagram below. Okay, so this is a resistor. This is a circuit arrangement. So the current flow is 13 amp. Then these are 3 resistors that are in parallel. So you are going to first of all find their effective resistance so that you can get the potential difference. Okay, so what you are going to do first of all is to find the effective resistance or the overall resistance. And so overall resistance 1 over R is equals to 1 all over 2 plus 1 all over 3 plus 1 all over 4. Okay, so this gives you the LCM of 2, 3 and 4 is 12. So 2 divided 12 is 6. 3 divided 12 is 4, and 4 divided 12 is 3. So when you add this up, you are going to have 13 over 12. 13 over 12. So I over R is equals to 13 over 12. Your arrow now will now be equals to what? Will now be 12 over 13. It's 12 over 13 ohm. Now you have, they are giving you the current to be 13 amp. So if current is 13 amp, from V is equals to I arrow, V is equals to I arrow, we can substitute into this equation to get our potential difference. V, I is 13 and resistance is 12 over 13. So this can cancel out, so that you have that your V is equals to 12 volts. Okay, so your V is equals to 12 volts. Now we are asked to find the current through the 3 ohm resistor. So since you know that your V is 12, is 12 volts, that is your PD is 12 volts, and don't forget that for a parallel arrangement, the potential difference is the same. It is the same potential difference. I hope you remember that. Okay, so the potential difference is the same. So from also the V is equals to I arrow. In this particular instance, our arrow is not 3. Our arrow is 3 ohms. So the current will be equals to V all over arrow, which is equals to 12 all over 3. And that gives us current to be equals to 4 amp. Okay, so the current flowing through the 3 ohm resistor is equals to 4 amps. So okay, the same thing you can do for the 2 ohm resistor and the 4 ohm resistor, but at the end of the day, the sum of this individual currents will be equals to 30 amps. Okay, so you can try it. You can use this method now. Solve for the current for the 2 ohm resistor, solve for the current for the 4 ohm resistor, and then add up together. They should give you 13 amp. Okay, so these are ways, or these are the method of solving problems in current electricity. As I say, this is just introduction. Is that okay? So as we go further in some other lectures, we'll be bringing up more detailed information and more advanced questions to solve. All right, so thanks a lot. Let's go straight to your test page. So guys, this is your test page. I want you to try your hands on them. These are very simple. Please, we've solved something like this before, so I don't expect that you have any challenge here. Now, what you will do here is that the way you did here, first do it here. Find the overall resistance here. Find the overall resistance here, then make everything to be series and add up and get your overall resistance. That's okay. So that is just how to go about this one. Then this one, you have a 12-volt battery supplies a current of 0.4 to a line. Calculate resistance. V is equals to I arrow. That gives you that one. Then a 24-volt potential difference applied across a parallel combination of 4 6 ohm resistors. The current in each resistor is, this one is as simple as, this is a jam question. So what you do here, just draw the circuit, arrange the 6 ohm resistor 4. There are 4 6 ohm resistors in parallel. They find their combined resistance. Is that okay? Find their combined resistance. Then, but in this particular case, you know that the current that is flowing through the individual resistor is different. Is that okay? So what you do here is just for you to divide. What you do here is just for you to divide the voltage that is given to you by the current, by the resistance, for you to get the current that is flowing. All right. So since you are not asked to find the combined resistance, you might not need to go that way, but I would prefer that you draw it so that you at least understand it. Draw the 4 resistors. When you have drawn them, then you use your, since the voltage is the same, the way we did in the equation I saw just now, divide this by this, you get the current that is flowing. Alright, so guys, thank you so much. This is where we are stopping our class for today. But before we leave, please give us a thumbs up. Click on the subscribe button now. Click on the subscribe button, not the one that is on this screen, but the one that is showing on that. Click on it, click on the notification bell so that when we upload a new video, YouTube will notify you. This is Numberman Science to Source Online. We are bringing physics direct to your very doorstep. You can also reach us through the WhatsApp number that is showing on your screen, or you can click on the link, the links to the videos that are showing under this video. Right, click on those links, will take you to our WhatsApp page, or they will also can take you to our playlist, right, so that we see all the videos that were uploaded. It's not only this video, we have so far we've uploaded more than 70 videos, so you can actually look at them, look at the topic that you want to view and click on that topic. Okay, we have about 70 videos and we are still bringing in more. So click on the video that you want to view, look at the topic, click the one that interests you, listen to the video. Definitely you will have one or two benefits from listening to the videos. Invite your friends also to come and watch this video, and let them also subscribe. So subscribe and give us a positive like, give us a thumbs up, so that you continue to encourage us, right? So thank you so much for your time. We appreciate you so much. We'll see you in our next class.